Our next paper is by Nideesh Prathi, Elemental Composition and its Molecular Influence on Prebiotic Chemistry on Earth. He's from Bal Bharati Public School, Pitampura.
Hi, good morning, Nideesh.
Good morning to all. Hi, I'm Nideesh from Class 9 Balbharti Public School Pitampura, and today with you I'll be discussing my project which is named Exploring the Role of Minerals in Prebiotic Chemistry on Earth and Beyond. So I chose this topic because since a very long time I had very intriguing question, which was how did life start on a planet with non-living things and with very harsh environment, for example frequent volcanic eruptions like Earth. So this is an interdisciplinary project between astronomy and biology, so it is thus called astrobiology. Clays were studied because when they swell, they create a protective layer for organic materials to react with each other, thus helping in facilitating of life. They have a special ability called CEC, which is basically cation exchange capacity, which helps them to attract useful material for in this project RNA. So in this project we found out that montmorillonite can swell up in an optimum ratio of 2.5 between the ratios of silica to aluminium and aluminium to iron. So which we found out by a literary analysis. So this study analyzed three clays, namely montmorillonite, illite and nontronite, and examined their elemental compositions, which I have mentioned before, and comparing their swelling area, surface area and swelling behavior when they interact with water. So this is the mineral composition of the three clays, which I have taken from the authoritative Clay Mineral Society. So in this study, we basically measured the cation exchange capacity, which I mentioned before, helped the clays bond with more useful chemicals and molecules. This was an exploratory secondary study which analyzes these clays by looking at their elemental composition and deriving which clay could have facilitated life on Earth. So this is the working. So the methodology is we took the three clays and we examined their chemical composition when it swells up while interacting with water, and saw which one has an optimum ratio of silica to aluminium and there. So the conclusion was, after we found the ratios, montmorillonite shows the most favorable chemistry for RNA absorption and protection. Illite shows moderate suitability, and nontronite, because of its low aluminium to iron ratio and high silica content, was classified as poor RNA preserving mineral because we needed a stable environment for the RNA to reproduce. Since this is a secondary study based on collecting and analyzing data, I actually didn't do any chemical work in the lab. I just took the chemical composition and just analyzed it. I took out the percentage ratios of silica to aluminium and aluminium to iron, and as I have told you before, surface area and swelling behavior were compared between the clays. So these are the references. Thank you for listening to me.
Yeah, thank you, Nideesh. Over to you, Dr. Khushbu Sahu.
Yeah, okay. Thank you, Nitesh. And this was really, I think so. This is a good, study. to, for the future research. But initially, you have started it very nicely and you have presented it in full confidence. I really appreciate that. And for the question, kindly go back to your first to second slides. Yeah. So I hope, I mean, you have done the background study, right?
Yes, ma'am.
Yeah. So why this, silicon aluminum ratio is, important in prebiotic chemistry? Why is it important? Can you just give me an overview or just a simple, answer?
Ma'am, ma'am, these ratios are important because while looking at the mineral composition, we I compare these ratios between the clays to check out which clay is chemically stable and which can help RNA to reproduce. So too much is not good, too less is also not good. So we look at the optimum ratio.
So why this matters? Why this matters for the prebiotic study? Why?
Ma'am, because it creates a chemically stable environment.
Okay. So this prebiotic reaction, what happened in that is that they needed a surface that actively this help molecule to link together, isn't it?
Ma'am, could you please repeat?
I mean, these, prebiotic reactions needed this surface, right?
Yes, ma'am, they need a good protection.
Yeah, they needed a surface so that this help the molecules to link together. That you have given me example of what the RNA stuff, right?
Yes, ma'am.
Yeah. So so you also talked about this cations and ion exchange, isn't it?
Yes, ma'am. CEC.
Can you explain, elaborate more on that? Because I want to know about this background. I mean, how you came to this I mean, you have read about the literature review, right?
Yes, ma'am.
So what is the gist of it?
Ma'am, so CEC is basically cation exchange capacity, which is the ability of a clay to attract and bond with more useful chemicals, like for example, in the study RNA.
All right,
So
all right.
for a better ratio.
Yeah, okay. So why did you select this topic? And I mean, just want to know about it. Why do you selected this topic? Because this is a pretty interesting one, and it has a a very good role in possible research, future research. So why do you selected this topic? What interests you in this?
Mom, so basically, I'm an animal lover. So I like for time pass, I traced out all the origins of all animals, and then I got intrigued with a question: how did life literally start on Earth? Because I got to know that Earth was like a giant magma ball
Yeah,
with
yeah,
a very harsh atmosphere. So I was like
exactly.
very curious.
Okay, wonderful, wonderful. So, so this is like you talked about all these clay and how does this montmorillonite aid in RNA world hypothesis, isn't it?
Yes, ma'am.
So this was I mean I really like that when you compare the different types of clay using these literature reviews. But have you ever worked on the data sets? I mean, have you gathered more data sets on this?
No, ma'am. I have just done the literature review. I've read the articles, uh, like associated to Montmorillonite and RNA fusion, and yeah, and I've took out the mineral composition and just derived the
Yes.
ratios.
Okay, so what do you think? What will be your next step?
Ma'am, next step. Ma'am, next step, I think how would this research help in finding life on other planets? Like, as we know, all of the space organizations are now trying to find life on, for example, Mars. They're finding water deposits there. So I think this could
Yeah.
help.
Yeah. Okay, then. I mean, it is really, I'm really impressed with the way you presented it. Okay. So we should now keep it. I mean, Thank you for the presentation you gave, Nideesh. Hope to
Thank you,
see
ma'am.
the wonderful the paper coming up. Okay.
Thank you, ma'am.
Yeah.